So it looks like around the room that every table has agreed that the first one is not one that you agree with. And that's because when we multiply with like bases, in this case, we have like bases. X is the base. We keep the base the same. We never do anything with the base except for to just record what the base is, and we add the exponent. So this is 3 plus 4, which is x to the 7th. So everybody was okay with that. That's good. The second one, I have a check, a true, and one table disagrees. Okay, so what did they have? A squared, a to the third. Okay. All right, so when we have a division problem involving exponents, well, first we have two numbers. We have 35 over negative 7. We can separate this into 3 separate fractions just like this, so it's all multiplication. So this is just your normal division as you normally would do it. 35 divided by negative 7 is negative 5. And so it seems like the issue is right here with what you do with the exponents. So let's take a look at this one first. This says b times b times b times b times b times b over b times b times b. Every time you have a common factor, it creates a factor of 1. This is called reducing fractions. So that's just one big 1. And what's left is b times b times b. And what does that give us? B to the what? Third, right. So when you're dividing, you subtract your exponents. So this is correct. Okay, so that is correct. You don't divide the exponents themselves. Just like in this first case, you didn't multiply the exponents, you added them. When you divide, you do not divide the exponents, you subtract them. Notice multiplication and division are inverse operations of each other. They undo each other. So the properties are inverses. With multiplication, you add. The inverse of addition is subtraction. With division, you subtract. Okay. The next one, I look around and it looks like table 1 says it's 31 square roots of 2. Table 2, 31 square roots of 31 square roots of 2. Okay, we're all set with that one. True. The next one is false on table 1, false on table 2, but a different answer. And table 3 says false with the same answer as table 1 and table 4. So all three out of 4 tables agree that the answer is 16x to the 4th minus 8x squared plus 1. This is a very common mistake to make. And this is one that you should highlight. If you bring a highlighter to class, often you'll see me highlight stuff. If I had a highlighter, I would have a big highlighting right through here, and I would make notes to myself, because this is a really, this is something that students often do. They confuse exponent properties that apply to things inside that are products or division problems. All your exponent rules apply to either something that's being multiplied or something that's being divided. Notice this has a subtraction in it. So these things are called terms. This is like a binomial, a polynomial. Totally different story. You use the basic meaning of an exponent, which means you just write out what this is, using the definition of what it means to square something, and then you use your distributive property twice. So this is 16x to the 4th. Your middle and outer term will always be exactly the same whenever you square a binomial. In this case, it's 2 negative 4x squares, which is negative 8x squares, and then negative 1 times negative 1 is 1. So this was false. Okay, number 5, when I look around the room, I see okay, 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 and nothing. This is true. If you have any questions, let me know. Is that true? Yep. Because 2 take away 5 is negative 3, so the 3 goes downstairs. And what does that say? 13 take away negative 2 is positive 15. This one always gives people trouble. Many of you can come up with the one that something raised to the 0 power is 1, but it's the 32 to the negative 2/5 that you forget. This is the root that you take. You're taking the 5th root of 32, which is 2. And then you raise 2 to the negative 2 power. If 2 is just raised to the 2nd power, it would be 4. And because it's negative, you say, I'm going downstairs instead of in the numerator. So it's 1 take away a quarter, which is 3/4. So some of you had 1 1/4. Some of you had question mark, a lot of question marks. And that's typical for first day of 107. A lot of students can't remember how to do that. We okay with that now? All right. So this is false. 7, what do we have? True, 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 and true. All right, then we don't have to talk about that. 8, true, 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 question. All right, so 8 is a multiplication problem. So the best thing to do is to just multiply those two things. Get the square root of 300, which is the square root of 100 times the square root of 3, and that's 10 square roots of 3. So that's true. 9, false, true, false, false. Okay. 3x take away 4x is negative 1x. And then 5 take away a negative 7 is 5 plus 7. So this should be negative 1x plus 12. Okay, so that's false. Okay, and this is just your typical using a distributive property twice. I think everyone has that. Yep. And then the last one, again, is one of those ones that I would highlight if I were you. It's one where we have a real big misconception. To get that fraction, you would have had to add 2 fractions with the same denominator. The denominator that belongs to them belongs to both of them. That x belongs to the x squared, and it belongs to the 5x. So if you separate, this is a single fraction. If you separate it out to 2 individual fractions, you could reduce each one. X squared divided by x is x. 5x divided by x is 5. So the answer here is x plus 5. Okay, you cannot just cancel this x with just a piece of that. And that's why I purposely gave you this answer, because this is a typical error that student makes. Okay. All right, so let's do the demo. You all did a great job. You worked hard on that. And the demo is going to involve some of the same things that you did, but I'm going to give you a little more explanation. And notice that the first problem deals with exponents. And it has, you have to have the properties of exponents down. When do you multiply exponents? When do you add them? When do you subtract them? Those basic exponent properties are located in section P2. If you need more review than the problems I gave you for homework, just click on similar example on my math lab. You want to do this so that you don't even have to think about it too much. Okay, so there's 2 things going on here. You have to know the exponent property for a product raised to a power, because this is a product. Anytime you multiply a bunch of stuff, it's called a product, and it's being raised to a power. So you need to know what to do with something that looks like this, a product raised to a power. That's the first thing. Then you need to know, what do I do with a power that's a fraction, like 1/3? Okay. So the first property says when you have a product raised to a power, the shortcut is that each one of those factors, whether there's 2 like in the case of AB or 3 here, each one gets raised to that exponent. Okay, we have to be fair and square here. Every single one of these factors gets raised to the 1/3 power. People often leave out the constant number. Poor constants, they're always being left out. So this is 64 to the 1/3 times x to the 300 to the 1/3 and y to the 600 to the 1/3. Okay, so that's what it looks like. Okay, so 1/3 the power of 1/3 says the same thing as take the cubed root. That's what it means. The number downstairs is the root. And this time of year, we're going to start collecting carrots and beets and potatoes. And where do we put them? If you grew up on a farm or you know anything about farming, where do we store them? We don't know anymore, do we? In the cellar. All right. Your roots go in the cellar. The roots are in the denominator, okay, in the bottom. That's your root. So the cubed root of 64 is 4. Now what do we do? Now we need a new exponent property right here. This is called a power being raised to a power. And the property there is to multiply your powers. So x to the 300 becomes x to the 300 times 1/3. And y to the 600 raised to the 1/3 is 600 times 1/3, which means you just chop them all by 3. You divide them by 3. So 4x to the 100 times y to the 200. And that's your simplification. Okay? So notice we had 2 different exponent properties in that problem and the meaning of a fractional exponent. Now that we've done fractional exponents, can someone help me with this one? Now that we've discussed it twice. Yep, go ahead, Jacob. Yep, we're going to take, this is what we're going to do first. Do we have to do it first? Absolutely not, but it's always easier to make your base as small as possible. So Jacob says we're going to take the cubed root of 8 first. Okay, so let's do that. When we take the cubed root of 8, what do we get, Jacob? 2. And now that we've taken care of the cubed root, we're only left with a -2. So this is what the first step would look like. 2 to the -2, and now it looks like the problem we just had for the preview exercises. This is 1/2 square, which is 1/4. Okay. I'm going to show you another. Lydia, do you mind getting that door, please? I'm going to show you another way to do this that students don't often think about. Anytime your base is a perfect, whatever your root is, so in this case, whenever your base is a perfect cube, because that's the root we're taking, you could rewrite 8 like this. 2 to the 3rd, that's 8. And now use the same rule you used up here. You have a power to another power. Just multiply. And when you multiply those two numbers, notice your 3's cancel and you get 2 to the -2, which is 1/4. It's just another little shortcut. Okay. I think you all did a great job with the radicals, adding and subtracting. You need to make them like, so you look for a number that divides 12 and divides 27, and you get 3. So once you do that, you rewrite the radical as a product that involves the square root of 3, and we luck out. We're very happy when we see this because that's a perfect square. So 3 times 2 times the square root of 3 minus 3 square roots of 3 is 6 square roots of 3 minus 3 square roots of 3, which is 3 square roots of 3. This is fast because it's prerequisite. I don't normally work this fast, just so you know. Factor, factor, factor. One of my favorite things to do, but often not a favorite thing for students. The most important type of factoring, first of all, what does it mean to factor? This is a verb. It means to take that addition and subtraction problem and rewrite it as multiplication. That's why the word factor comes in. Okay? And the first form of factoring you should always think about, no matter what type of problem you have, is the greatest common factor. That's your friend. So when you look at that multiplication, that subtraction problem, you say, is there a number common to both of those? And the answer is yes, 5. It's a factor of both. I can divide 5x cubed by 5, and I can divide 45 by 5. And is there a variable that has a power that's common to both? And yes, they both have x as a variable. You have 3 factors of x in the first term and 1 in the second, so they each have 5x as common. So what you do is you put 5x in front and you say, okay, if I had 5x cubed and I divided it by 5x, what would I be left with? I'd be left with x squared. So that goes right here. And you put your subtraction. And if I had 45x and I divided it by 5x, what would I have left? 9. And you're so proud of yourself, you think you're done, but you are not, because the second factor is the difference, because it's subtraction, of two perfect squares, which always has a factoring that looks like exactly the same thing, but one is addition and one is subtraction. So this is what we call completely factored into prime factors. You can't factor any one of these factors any further. They're all prime. Okay. So again, factoring may be one of the sections you have to spend a little time on. Again, reduced to lowest terms. What we don't want to see here is this kind of thing, like that, and a 2 going in. You know, that is like totally bogus, because this denominator, x squared plus 2x minus 8, this entire denominator is part of each one of these. So you can't separate it out. So if you understand that when you reduce something, you are finding factors of 1, which means that each of these polynomials on top and bottom need to be factored. So this is another form of factoring that probably you're familiar with. So factors of 10 that differ by 3, this is how I factor anyway. Factors of 10 that differ by 3 are 5 and 2. Do x and x. I end up with a positive 3x, so that means my 5 carries the positive weight and my 2 carries a negative. And now the bottom, factors of 8 that differ by 2. X plus 4, x minus 2. And now you look to see if there's a common factor on the top and bottom, and there it is, x minus 2 over x minus 2. So your answer, and keep it in parentheses so that evil temptation will not lurk up and want you to cancel out those x's. Those are two very different numbers. They have nothing in common. It can't be reduced any further. Even if you put a number in for x like 10, you'd get 15 over 14. You can't reduce it any further. So once you drop those parentheses, then you kind of, your eyes see the x over x and you're very tempted to cancel. You can only factor out ones as factors. So if there's a bunch of pluses and minuses between things, you can't touch it until you factor it like we just did. Okay, and then the final thing, and this is probably the hardest part, and it's where you ended 096 most recently. This was probably the last topic you covered, and I think this is P5 in our textbook. It's probably the section you're going to need the most help with and the longest time. And here you have an addition problem with different denominators. So this looks a lot like this, for example. If I gave you a problem like this, how would you do it? You'd make the denominators the same. And what's really nice about these denominators? You can just multiply them, right? Because they're both prime, yes? So you could convert both of these to 21s. And you would multiply the top and bottom of this one by the other's denominator because they're prime. You see, like this. Guess what? Look at your algebraic fractions here. X plus 2 and x minus 2, those are already prime, just like the 7 and the 3. In fact, how did I make up this problem? I let x in my mind be 5. So I got 5 plus 2 is 7 and 5 minus 2 is 3. So to get your common denominator here, your common denominator, your least common denominator, or your least common multiple, however you want to think about it, is the multiplication of those two things. So this first fraction wants to have x plus 2 times x minus 2 on the bottom. So since we inserted x minus 2 on the bottom, we have to do it on top and bottom. And then the next one has the x minus 2 on the bottom, but we want it to say x minus 2 times x plus 2. So we have to take the x on top and multiply it to keep everything equal by x plus 2. Now we have the same denominator, so here's where I get a little bit lazy. I put one big long fraction bar like this, and I put LCD. I don't bother writing it out at this point. I just do LCD, and there's a reason for this. I'll tell you later. So then you do this, 3x times x, you get 3x squared. 3x times negative 2 is negative 6x. And we're lucky here because it's addition, so we don't have to worry about that subtraction sign distributing through. And we got x times x is a positive x squared, and x plus 2 is 2x. Now we simplify this. 3x squared plus x squared is 4x squared minus 4x. Now put in your LCD. X plus 2, x minus 2. So what do you notice? The bottom is in factored form. It's multiplication. The top is a subtraction problem. If we're going to reduce this, we need to be able to find a common factor to the top and bottom. Okay? So you have to factor the top. How could I factor the top? Can anybody help me with that? 4x. Let's pull a 4x out. And what do we have left? X, take away 1. Are there any common factors top and bottom? I don't see any x minus 2's in the top. I don't see any x plus 2's in the top. So this is reduced. So you can either leave it in this form or this form because you can't reduce it any further. Right? So that's a quick review of the first P2 to P6. I don't expect you to have all this material reviewed by Friday. And so if you look at your class activities for the next 10 minutes, it says this is a long activity and a lot of material to review. If you don't finish today, work on it at home. There will likely be additional class time next class to continue to work on it. So do as much of this as you can now, today. Get help on the stuff that you need, but your first homework assignment, if you look on the back of class number 1, notice it says your first class assignment, your first homework assignment, it isn't due until next Wednesday. That gives you time to get set up in my math lab. It also gives you time to do this review. Your first 3 assignments are all due next Wednesday, so you don't want to wait to the last minute to do all 3 of them. But that way it just kind of gives you time to kind of get your footing and get going, okay? So what I would suggest that you do, notice I haven't gone over the syllabus, right? So you have to read that. I will take questions on Friday, okay? I will take questions on Friday. So what you should do now, you have 7 minutes left, is look at these 16 problems and start with the ones you think you're going to have the most difficulty with while you have your classmates here and you have my help, okay? All right, now, let's see.